All right, let's look at homework. So let's look at homework that I have not. No, I do not. So many things. Okay, here it is. Okay, the first 6 you're just graphing. Today is not a good day for me to post a graphing video because where I am currently, I don't have access to a whiteboard. But we've been doing graphing, so I'll do some of them tomorrow, and I'll post the how to graph video at some point. Not today. So they're all linear, they're all written in slope-intercept form. So you can either make tables and substitute in like values for x, like x equals 0, 1, 2, and then graph. Or you can graph just based on, okay, for instance, number 1, this is in slope-intercept form, so 2x minus 7. The slope is 2, the y-intercept is negative 7. So I would start at negative 7, and then the slope is just 2 over 1, so I go up 2 over 1, up 2 over 1. Or you can just plug in points. Number 6, f of x equals x. That just means x is equal to y. F of x, g of x, that just means y, right? You know that? It's just a different way to write it. You can change f of x or g of x to y in your head if that makes it easier. Anyways, so x is equal to f of x. So if x is 1, so is this. If x is 2, so is this. If x is 3, so when you're graphing it, it's going to be x is 1, y is 1, x is 2, y is 2, x is 3, y is 3, so on and so forth. And then the point of intersection is when they cross. All right, this is what we are doing in class. State where it's increasing, decreasing, or constant. What if it has a minimum or maximum. And I told you did not have to identify the domain or the range. We'll do that in class tomorrow. Use interval notation. That just means write it how we are writing it in class. Oh, I can't comment on it yet. There it is. So like, for instance, when is this decreasing? There are a few different spots where it's decreasing, but the first time I see it decreasing is right here. There to there, it is decreasing. So that's negative 10, negative 11, negative 12, negative 13. That's negative 13, and it decreases until negative 10. So that's one interval where it is decreasing. Another interval where it's decreasing. That's increasing. Okay. It's also decreasing from, this is negative 2. All the way to 5. So that's where this graph is decreasing. Okay, and then you would write down where it's increasing in the same way. And then you just have to identify the minimum and the maximum. So the maximum is the highest point. The minimum is the lowest point. Number 9, same thing. Number 8 is an exponential, and so you can't see it. There's an arrow pointing this way. So this function, this graph is going forever up this way and forever this way. Okay, so it is decreasing the entire time. So you would write, oh, that's not where I want that. So decreasing, it's decreasing the entire time. It's going like that. And it's getting closer and closer to 3. Yeah, it's getting closer and closer to y equals 3. It's not ever going to touch that line, but it's getting incredibly close to it. Anyway, it's decreasing from negative infinity. I don't know if I have that on here. Can I write infinity on here? Probably not. All right, well, you would use the infinity sign. Nope. What's better? Nope. Anyway, so it would be negative infinity, comma, positive infinity. It's always decreasing. Sorry, I'll figure out how to do infinity on this. Maybe, or not. And then the maximum Well, it is going forever up this way. So its maximum is also going to be, so maximum. There's really no maximum. It is approaching infinity. What about a minimum? No minimum, because it's literally continuing on forever. It is approaching, it's approaching 3. You see how this is y equals 2, this is y equals 3? It looks like it's on that line. It's not actually touching that line. It is getting as close to that line as possible. It is approaching 3. What else do they want? Oh, and then I told you not to do domain and range. All right. So that one's a little harder. We'll practice tomorrow, but you guys can do it. Number 9. Okay, these. So you're writing equations for the given tables in both recursive and explicit form. So first thing you're going to look at is it arithmetic or geometric? If it's arithmetic, it's going to be a linear equation. If it's geometric, it's going to be exponential. So like number 10, what's going on? They're subtracting 3 each time. 5 minus 3 is 2, 2 minus 3 is negative 1, and the ends are just going up by 1. All right, so y equals, my slope is negative 3 over 1, which is just 3. And then what's my y-intercept? They don't give it to me. I have to figure it out. But this one you can just figure it out using the pattern. Okay, well, when n equals 1, f of n is 5. If it's 0, then I would just add 3, so it'd be 8. So you do the pattern backwards. So that would be the explicit equation, the recursive equation. Let's do f of 1 equals 5. So the first term is 5, and then f of n equals previous term. Okay, you write previous term, and then what are we doing each time? We're subtracting 3. This one is geometric. They're multiplying by 2 each time. So y equals, once again, you do not know your y-intercept. They do not give you n equals 0 and f of n is something. But they're multiplying by 2 each time. So I just have to do the opposite. I'm going to divide 6 by 2, which is 3. So 3 times the pattern, which is 2. And then raise that to the n power. Or sorry, to the f power. Or you could be writing f of n. Either one's fine. And then, or you could just use the first term and go f of n equals, the first term is 6, the pattern, and then you would just have to raise that to the n minus 1 power. That means exponent, okay? 2 raised to the n minus 1 power. All right, that's that one. Careful, they start being obnoxious and their ends no longer are going up by 1. So you have to look out for your n. So like number 14 is exceedingly annoying. So let's do number 14. So they give you, when n equals 2, f of n is 5, and then they don't give you 3, 4, 5, or 6. They just jump to 7. So we have to fill in the missing terms. Like, remember this was the first chapter where you had to fill in a table of geometric terms. Let me see if I have, nope. Let me pull it up real quick. Okay, insert a table. So we have n, that's an f, we have n, and so they gave us 2. When n is 2, f of n is 5, 3, 4, 5, 6, 7. And then when n is 7, f of n is, hold on, I have it written down. Or I have it in the book. All right, 15,000. 625. All right. So we need to figure out what the pattern is. What's the constant ratio? Remember, we're just filling in missing terms. Well, I don't know why I put 2 so far away. Well, I guess we can do that. 1, 2. Okay. You don't have to fill them in. You just have to figure out the pattern, and well, that's really it. You need to figure out the pattern. So I'm going to take 15,625 divided by 5. 15,625 divided by 5, which gives me, I don't know, 3, I don't know. 15,625 divided by 5. Oh yeah, gives me 3,125. Then, thinking back to chapter 1, you either have to subtract the corresponding x values, so 7 minus 2, 7, 2 equals 5, or you can count the number of jumps. You'll get the same thing. 1, 2, 3, 4, 5. So 5. Then you take a random variable. I'm going to take d. I'm going to raise it to the 5th power. So some number times itself 5 times is equal to 3,125. And so you can use a calculator, or you can type into Google 5th root of 3,125. And it will tell you that it is equal to 5. So d equals 5. That's our ratio. So we're multiplying by 5 each time. So if we were to fill in the terms, we would go 5 times 5 is 25, times 5 is 125, times 5 is 625, times 5, is 3,125. And then that times 5 is 15,600. Okay. So we found our ratio. So then for your equation, you can just write y equals, I would just use the second term, or you can figure out the y-intercept. But you can use the second term times the pattern raised to the n minus 2 power. It's n minus 2 because I'm using the second term. If I was using the first term, it would be n minus 1. If I was using the y-intercept, it would be just n. All right, so then we could figure out, okay, what is the term before 5? So our pattern is we're multiplying by 5 each time. So what number multiplied by, so now if I'm gonna go backwards, I have to divide by 5. So 5 divided by 5 is 1. 1 divided by 5 is 1/5. So you can also just write y equals 1/5 times the pattern, which is multiplying by 5, and then raise that. Oh, that was really small. Yeah. So either one is fine. And then for recursive, it would be, so let's see, f of 2, just identify the first term they give us, which was 5. So f of 2 equals 5, and then f of n equals previous term. And then what are we doing to it? We're multiplying by 5. Insert equation. There it is, times 5. There you go. So 13, no, really 12. 12 through 15, no, 15 doesn't do it. 12 through 14, the ends do not count up by 1, so they get tricky. Yeah. Okay. I think that's it.